Today we're talking about section 1.1, the second half. We're going to call it part B, graphing quadratic functions in standard form. As a warm-up exercise on the top of your paper, you need to graph the functions, label the vertex, and the axis of symmetry. So please take a second before you start the video and do those two problems. There are two graphs there. Once you're set with your warm-up, we're going to move into the key concepts. The minimum and maximum values. The first, in terms of minimum value, is that the vertex's y-coordinate is the minimum value. Right? So the vertex's y-coordinate is the minimum value when, and this is when A is greater than 0. So when A is positive. And the maximum value when the vertex's y-coordinate is the maximum value when A is less than 0, or when A is negative. This is something we talked about in the last video, but just as a quick reminder, you always want to be sure you know which direction your parabola is going in before you start graphing. So example number 3 asks you to graph y equals 2x squared minus 8x plus 6. So as we work through this problem, we're going to do a couple, but I just want to point out the key steps. First, you want to identify the coefficients. And the coefficients are A, B, and C. Right? And we're using these in a lot of formulas, so we want to make sure we know what they are and they're clear. So I always write down the coefficients before I start. A equals 2, B equals negative 8, and C equals 6. Notice I did write negative 8 for my B. That is because the original formula, ax squared plus bx plus c, implies that b is a positive value because there's a plus b. So if the equation that I'm given has a negative b, it means that the value is actually negative because it was supposed to be positive, but the value is declared as negative, so I'm going to write it as negative. Now I'm going to think about the vertex, right? Actually, first of all, does my graph open up or down? Well, A is 2. 2 is greater than 0. So my graph is going to have a minimum value, which means it's going to open upwards. So that's just good to know ahead of time. Before you start calculating, you kind of want to know what direction your graph goes in. Then we can think about the vertex. So the formula for the vertex I gave you in the last video, the x-coordinate is equal to negative b over 2 times a. So in this case, I have negative 8 over 2 times 2. Because I have a double negative, it turns into a positive. So I have 8 over 4 equals 2. So the x-coordinate for my vertex is going to be 2. But what's the y-coordinate? All I have to do is plug in the x-coordinate into my original formula, or my original function, and I'll be able to solve for the y-coordinate. So y equals 2x squared minus 8x plus 6. I just plugged in the 2 that I found for x, and now I can solve. So 2 squared is 4, and then 2 times 4 is 8, minus 8 times 2 is 16, plus 6 equals 8 minus 16 is negative 8, plus 6 is negative 2. So that is y equals negative 2. So the coordinate for my vertex is positive 2 and then negative 2. So this is my vertex. I'm just going to mark that so I know it. Then I can draw my axis of symmetry. My axis of symmetry is vertical. It goes right through the vertex. So I can really do this however I want, but I'm just going to do that for you so you can see it. You don't have to draw it. A lot of people like it just as a frame of reference to figure out where your middle point is. Now you can solve for some other coordinates. And the way you can do this is by using an input-output table and substituting for the functions. Whoops. So specifically, I know some people like to track their coordinates in a table. Personally, I don't mind. It's whatever I'm in the mood for. Because I know my graph is going to open upwards, I'm only going to solve for x values on either side of the axis of symmetry, right? I'm going to look at maybe 3 or 4 or 6. It's up to you, really. I wouldn't go too far away from the vertex because I just don't want to make things difficult. So actually, I'm going to start with the x value of 1. So I'm going to say when x equals 1, what is y? Well, my equation is y equals 2x squared minus 8x plus 6. So 1 squared is just 1, times 2 is 2, minus 8 times 1 is 8, plus 6. 2 minus 8 is negative 6, plus 6 is 0. So when x is 1, y is 0. So I'm going to plot another coordinate point. What about when x is 0? Y equals 2 times 0 squared minus 8 times 0 plus 6. When x equals 0, 0 squared is just 0, 0 times 2 is 0. Negative 8 times 0 is 0, y equals 6. So when x is 0, y is 6. X is 0, y is 6. So at this point, I have 2 coordinates on the left-hand side of my axis of symmetry, and I'm going to reflect them over to the right side. So my first coordinate is 1, 0, and it's 1 space away from the axis of symmetry, so I'm going to reflect it 1 space away on the alternate side. My second coordinate is 0, 6, and it's 2 spaces away from the axis of symmetry, so I'm going to reflect it 2 spaces on the other side. It's really that simple. It's not very complicated to reflect over the axis of symmetry. You just have to count the number of spaces and make sure that you're staying along the same x value, right? So your y value. The height of the coordinate is going to stay the same. It's just the horizontal distance from the axis of symmetry that's changing. Once you have 5 points, you can go ahead and connect them. Remember, a parabola is not linear. It's not a straight line. So you are absolutely not going to take a line and connect those dots into a V. It's not going to work, and it's incorrect. Parabolas do have a natural curve to them, so you are going to have either this U shape or like an upside down N shape. Example 4 says tell whether the function y equals 3x squared minus 18x plus 20 has a minimum or a maximum value, then find the minimum or the maximum value. This is just comparing your a. So in this particular problem, my a value is 3. 3 is greater than 0. And so my graph is going to have a minimum value. So I have a minimum. Okay? Then it says find the minimum or maximum value. We've discussed before that the vertex of your parabola, so the point where it's right at the bottom, is going to be the minimum. How do we find the vertex? Well, we can find the x-coordinate of the vertex with that negative b over 2a formula. So my b is 18, my a is 3, and remember there's a double negative, which I'm just canceling here. 2 times 3 is 6. 18 over 6 equals 3. So the x-coordinate is 3. What's my y-coordinate? Y equals 3 times 3 squared minus 18 times 3 plus 20. 3 squared is 9. 9 times 3 is 27. Minus 18 times 3 is 54. Plus 20. I like to combine my positive and negative integers before I actually solve them. So positive 20 and positive 27 is positive 47 minus 54 equals negative 7. So my coordinate for my vertex is 3, comma, negative 7. And that's where the minimum value is going to be. So the question asks me, is there going to be a minimum or a maximum? And then where is that value? So I answered both parts of the question. Last example for today, a go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize weekly revenue? So we're talking about revenue here. It is a function. Revenue is going to equal, if I have 380 racers per week times $35 for the charge, right? And what they say is that there will be 20 more racers. So if I have 380 to start, I'm going to get 20 more for every dollar reduction in price. So 20x, and then if the price is 35 to start, every time I remove a dollar, I'm going to reduce, I'm going to get those racers increased. Writing this function is harder than actually solving it. So I'm going to use a trick. It's called FOIL. You may have used it before. We're going to cover FOIL a lot in our next video, so I'm just going to kind of speed through this for you. FOIL stands for first, outer, inner, and last. It seems like a lot of information, but 380 times 35 is 1300, plus 380 times negative x is actually minus 380x, plus 20x times 35 is 700x, plus 20x times negative x is minus negative 20x squared. Now I just need to rearrange this problem here for myself. Negative 20x squared minus, plus 320x plus 1300. So I rearranged it so that it looks like y equals a x squared plus bx plus c, right? So now I have my a, negative 20, my b, 320, and my c, 1300. You should certainly be able to use those variables to find the maximum of this equation. To find my vertex, x equals negative b over 2a. So negative 320 over 2 times negative 20. So negative 320 over negative 40 is going to equal positive 8. And then I can plug that in for my y value is going to equal, and you'll just have to trust me on that, $14,580. So what does that tell us? Oh, my goodness. If 8 is x, then by decreasing the price of the go-kart race by $8, he's going to increase his revenue each week by $14,580. So actually by making the ride cheaper, he's earning more money, which is pretty gosh darn impressive. Lastly, make sure that you're working on your daily homework quiz. Again, this is not something that I do with you. This is something you do on your own. You're responsible to bring to class. These two problems tell whether the function y equals x squared minus 6x plus 4 has a minimum or maximum, then find it. Right? Very similar to what we did. And then in example 5, suppose the $1 reduction in price per racer brings in 40 more racers per week. How can weekly revenue be maximized? So same kind of question, it just changed the number of racers that we're adding. So that's definitely a trickier problem. Please try your best, do as much as you possibly can, and I will check it off for you in class.